Billy Krassakopoulos, President of WhiteFiber. My team and I have been designing, building, operating Tier 3 data centers for over 20 years now, specifically in a retrofit model. So we've gotten a lot of questions, what is a retrofit model? And what a better way to walk you through our latest retrofit, MTL-3, which we're handing over to our client, Cerebras, in a couple of weeks from now. So we'll walk through the facility. Sam and I will go through some of the key points to show you guys.
What was this facility before you turned it into a Tier 3 data center?
So this facility was a large textile manufacturing plant, specifically mattresses. So we identified the site. Basically, a major part of the retrofit strategy is finding a building with good bones, something with a good amount of power already in place that we can upgrade down the road. And we'll go through the details of the site. This site in February of this year, and a greenfield would have just taken too long to build for our customer. That's one of the first major points. Second major point, we are avoiding risks and costs associated with building a greenfield. Just putting this building up would have added a good 6 to 8 months to our schedule and millions of dollars in CapEx for the building itself.
We identified this facility in February and we purchased it, and you're now delivering it to Cerebras, a very well-known player in the AI space. How many months later?
Just over 6 months.
And do you think that would have been possible in a greenfield format?
A greenfield would have taken anywhere, best case, 18 months to do so.
So we're saving time and we're saving costs. And why do you say we're reducing execution?
We're not dependent on a contractor to put up the building. We're not dependent on raw materials. You know, there's a lot of talk about tariff wars going on. The building that we selected, and part of our due diligence, it's a building with good bones, a building that we don't have to do much work on to get it up to a Tier 3 data center spec.
So we minimize execution risk, we save time, we save money, and we get clients who are in a rush to get things up and running. And the only way we can do that is with your special retrofit approach. And this is just an example of one of them.
That's exactly it. We also have our Montreal 1 site, which has been in operations for just over 4 years now. That site was also a retrofit model. That's a multi-tenant site. It's not a purpose-built site like this one. So the team and I have lots of experience in converting these projects. So far what you've seen is the outer shell of the site. So basically we're building a box within a box, right? So that was the outer shell. We're coming up on the inner shell. So we'll see the cooling infrastructure, the white space, and the backup battery system room. So over here we have the glycol that's going to be going in the glycol portion of the cooling loop. This site is a direct-to-chip liquid-cooled site. We're coming up on the mechanical galley, so here we have all the mechanical equipment. Here we have the air handlers for the white space and the pumps that are pumping all the chilled water to the customer's equipment. It's a very complicated system, redundant, fully redundant. Any one portion of this system can be removed and the customer is still up and running.
And that's what, of course, that's what you mean by redundancy.
Exactly. Concurrently maintainable, basically at any time. You can maintain the system, there can be a failure in the system, and the customer is still up and running. So this is the heart of the operation, basically the box within the box where the customers, the end user's equipment will go. So over here you have aisles and aisles of cabinets, fully redundant power, cooling, general cooling of the room coming in through the vents, and direct-to-chip cooling from the manifolds underneath the raised floor. So here we have the power distribution units. These black boxes are really what feeds each cabinet. And behind that, we got their transformers, getting them down to the right voltage. And next to those, we do have the output panels. So those are connected to UPS battery systems that are in place just for the 10 or 15 seconds of utility failure, the time it takes for the generators to kick in. So if there were to be a utility failure, the end user would not realize it because of the battery systems. So over here we have a piece of the manifold that's underneath the raised floor. So basically each cabinet, each direct-to-chip liquid-cooled cabinet connects to one of these valves, and this is how they get their cooling. These are automatic shut-off valves. If anything were to happen, we can isolate and shut off one cabinet of the installation. Here we have the connectors. So each cabinet has 3 connections, redundant, so they need 2 to be live for the cabinet to be working. And this is how each cabinet gets its power. This metal structure here is the hot aisle containment. So once the cabinets are in place, basically we put plexiglass between these metal panels to keep the hot air confined within its space, makes the data center much more efficient, makes the customer's cooling in the front side of the cabinet much more efficient. So that was the white space. We're gonna go look at the electrical infrastructure that supports all this. So as you can see, a lot of work happening. We got over 120 people on site trying to make this delivery. Here we have one of our generator rooms. So these are in place in case of an extended utility outage. We got about just over 24 hours of fuel on site to support any long-term utility outage. Contracts with fuel providers to replenish the fuel within 4 hours. Over here we have battery rooms. So ABC battery rooms, 3 feeds again. Only need 2 to be live for the installation to be working. So we can maintain one of them, take one of them down at any time, and the installation is still up and running. And the batteries, again, really only for the 10 to 15 seconds it takes for the generators to start up and stabilize. So here we have the battery room. These are transfer switches, really the brains of the operation. These machines decide if we're running on utility power, battery power, or backup generator power. So even if there's a little blip in the utility power,
the system will take it over.
This will switch automatically to batteries. If it's extended, it'll switch to generators. So these are the battery systems. Again, really here for the 10 to 15 seconds that it takes the generators to stabilize once they start up.
All this for 10 seconds.
All this for 10 seconds. 10 seconds just for the customer not to drop their load and lose their connectivity.
Right.
So that was the tour, that was the box within the box. The retrofit model that shows how we quickly can execute a build like this for customers.
The market is catching on how unique your approach is with respect to retrofitting facilities that used to be manufacturing facilities like this one. This one used to be a mattress factory, and now you've turned it into a state-of-the-art Tier 3 data center for Cerebras, one of the most demanding hardware companies in the world. And you've done it on time, flawlessly, with 120 people working around the clock and just dealing with all the supply chain challenges. You've done this successfully. You've been doing this for many years, and really looking forward to working with you on all the other clients that we have coming up in the future in facilities that we've already identified across Canada and the US.